Welcome back to the second episode of this coding challenge where we're building a Mandala Maker, or a Mandala Maker, depending on how you pronounce that. And we're just going to pick up where we left off last time, but before we do that, let me just mention that in the comment section of the last video, Eddie left this outrageously excellent comment. So Eddie is an avid commenter on this channel, but Eddie, man, I think you outdid yourself on this one. This is some pretty serious stuff. So I would highly recommend that you check out his comment on the last video if you're interested in diving a bit deeper. So he was mentioning a few things. Firstly, he was mentioning that the function that I was desperately looking for, the Lambda function that I was desperately looking for, is called Juxt. It's Juxtaposition. We'll look at that in a moment. But then he was also emphasizing how to. I mean, so his whole comment was sort of in surrounding the idea of how to get rid of or simplify this array of transformations. So firstly, he's showing how we can simplify this array of transformations so that it's simpler. And then he's saying, well, I mean, maybe for this series we would stop at that point, but theoretically, you can go further and you can use the chain operator. So you can use the idea of monads in order to, if I'm not misunderstanding, actually get rid of this whole array of transformations and just significantly simplify that. So I didn't actually entirely understand that yet, so I need to dig into that a bit more. But the reason and also he's emphasizing you could also use pipe K, so Kleisli composition, or left to right Kleisli composition, because I guess Kleisli piping in that sense. And let me just show you here in the end, right? And then he's saying, well, your transformations could become here, right? Like additionally, if we use, I'm just reading from the comment, if we use pipe K, it is as simple as const pattern equals pipe K invert ref X ref Y. I mean, if that's the whole pattern, that just blows my mind, right? But maybe it's not the whole pattern, so maybe I'm misunderstanding this. But anyways, here's what we're gonna do. I actually gave this a bit of thought also before reading this comment yesterday, and then I realized that there's this thing called, or I don't actually know what it's called, but the way we can think about this is that we could think about this as rotating a point through a circle, right? Or I was just thinking like trigonometry. We probably just could solve this problem simpler by using sine and cosine, and I'm by no means a trigonometry expert, which is probably why this didn't come to mind initially. And we'll get into this in just a moment. But going back to this comment, I think we should try that approach. And then I will definitely have a look at this about trying to apply monads here, because I kind of intuitively see what you're saying, and I think it's sort of in line with what I was alluding to, in that maybe we could think about the next transformation as a consequence of the previous transformation, or something like that. It's like you're building up this array of transformations. But yeah, now I'm out in the deep end of the waters. So I think what we're going to do is, in this episode, we're going to try to use, I guess, trigonometry, right, to simplify the transformations, and then hopefully in the next one, I'll try and understand how you could use the monads as you're emphasizing. But anyways, even if I don't get to that point, to you as a viewer, I would highly recommend that you check through this comment, because it's theoretically very, very interesting. Okay, and thanks again, thanks a ton again, Eddie, for that comment. Great comment. Okay. Let's talk about juxt, right? Juxtaposition. So this is the function he was saying that we actually that we need when. I guess even that maybe we should do immediately, right? I guess that was in regards to this transformer, probably, or something like that. Let's think about this, right? So what juxtaposition does is that it applies a list of functions to a list of values. And maybe I can't remember if I did encounter this function when scrolling through the Lambda documentation in order to try to find the function I was looking for, but I probably got thrown off if I did see it by a list of values, because we actually want a list of functions applied to a single value. But actually, that doesn't really matter here, because if your functions have an arity of 1, like if your functions take a single argument, then you're simply applying a list of functions to a single value. And that's actually exactly what we're looking for. So if you look at their example here, you can see that they're constructing this function getRange as the juxtaposition of the array containing the two functions mathmin and mathmax. So, I mean, think about range, right? Like when you're describing a range in mathematics, you're describing it like this, right? Let's say the range between 10 and 20, like all numbers between 10 and 20, right? So that's what they'll be returning. They'll be returning an array containing two numbers that sort of like semantically describes a range. So this getRange function is the juxtaposition of mathmin and mathmax in one array, right? And so then they're saying getRange, and then they pass a bunch of numbers. And now mathmin and mathmax are both variadic functions, like the JavaScript functions mathmin and mathmax. So you can keep passing them any number of arguments. So that's why what happens here is that all of these arguments are run through mathmin, and the result is placed in the location in this array where mathmin is, right? So mathmin is the function at the 0th index, and mathmax is the function at the first index. And so all of these arguments are passed through mathmin, and then you get -3 back, and that's placed at the 0th index. And then all of the arguments are passed through mathmax, and that creates the 9, because the highest number of these numbers is 9, and then that's placed at the first position. And if you think about it, that's sort of what we were working with. What we were working with as well, because we have this list of transformations, and then you want to run our initial point through every transformation and just place that point that's a result of the transformation at the given index of that array. So what that means is that we are actually talking about, like assuming that we had this lambda function juxtapose, we are actually talking about doing something like this. Let's say we have this list of transformations, so we would say juxt the transformations, right? So we pass the transformations, and then we pass the second argument, right, which is the point, right? So x1 and then y3, for example, right? That's the first point that we have here. And let's think about that. How did we implement transform? So we've implemented the function transform. So maybe actually, yeah, so maybe then, yes, actually, so actually juxtapose is probably, the implementation of juxtapose is actually exactly the same thing as our transform function, except that our transform function assumes that you have a singularity function, which, I mean, isn't an insane assumption here, given that we are sort of on the fly constructing these general purpose functions. And if you've been watching my Ramda series, you know that I've mentioned a bunch of times that working with variadic functions is a bit tricky when it comes to partial application. So partial application and variadic functions don't mix very well, because if you have a variadic function, in other words, a function that takes an unknown number of arguments, like you can pass it 10 and that's valid, but you can also pass it 3 and that's also valid, then you don't know when the partial application is done. Like when you've passed another argument, should you consider that function partially applied or fully applied? And if you then pass another argument, should you then consider that fully applied or partially applied? So maybe it would make sense to just make this assumption of a singularity function, that the functions in this array are unary. But maybe, actually, it's pretty trivial. Let's think about that. We could probably also just do something like this. Like, let's spread the x. Maybe I should put this on 2 lines because my font size is so huge. So if we spread, I think it's something like this. I always forget the syntax. And then we thrush, but that also depends then on our implementation of thrush. So maybe we shouldn't spread here. Maybe we should actually spread here. So like thrush is maybe something that can take a number of arguments, and then we spread those x's. Actually, maybe is it something like that? I don't know if I should spread in both places. Let's actually try to figure that out, right? Let's comment out this juxtaposition line, and let's save this file. Let's map a keystroke to running this file through Node. Let's just make sure that we don't have errors. Yeah, and this seems to be sort of the result that we were working with last time. But let's now also console log. Let's thrush the value. Let's actually do this. Let's thrush 1 and 2 and 3 into the function math.max, right? Because that should give us 3. And that does give us 3, right? Can we handle any number of arguments? 5, 6. Yes, okay, it can. And let's just change the order for good measure. 1, 2, 5, 6, 1, 2, 3, right? Let's save that, let's run it. And we still get 6. Okay, so that seems to work. And let me just, so maybe let's comment out these console logs in the end, and let me move this thrush console logging up here so that we can talk about it in the same place. So I just want to emphasize that this happened now, or this worked now because we used the spread syntax. If I remove the spread syntax here, right? If I just change this for x as we had before, and then we apply the function to x, this shouldn't work, right? Because then we get 1, because then we're only applying the first argument. And I think we need to spread in both of these ends. Let me just make sure that I'm correct. Yeah, because otherwise we have a syntax error even. So we need to do something like that. Okay, and then that works. So then the question is, can we use transform with this implementation of thrush? So can we now transform a multi-arity function? So can I do, let's think about this. How do we try this? We do something like transform, and then we want to pass the function math.max, and then we want to pass the that needs to be inside of an array. So an array here, mathmax. Let's actually do their example, mathmax and mathmin, right? Let's do the Juxt example. They do, mathmin and mathmax, min and then mathmax, and then they're passing a bunch of numbers such as 3, 4, 9, and -3, let's say. Let's try that out. No, then we get 3, 3. So probably we need to spread here in the transformation as well. So okay, exactly, because of course the thrush operator now takes potentially multiple arguments, but yeah, so either we need to do that or we need to pass them as an array. So yeah, I mean, it might actually, so I'll do it variadically now, but again, like, I think the better decision here is probably to work with arrays and avoid variadic functions, even though JavaScript is variadic, because like in my mind, it just seems that the power of having variadic functions does not justify losing the power of partial application, because partial application is just too good, right? By the way, I sent a few links in one of the comments on the last video on some examples of videos in the Ramda series that have to do with currying. I think it was like let me try to find that actually very quickly, because if you're not familiar with currying or partial application, you should definitely look into it. It's just it's too good, right? Let's have a look here. Sorry, one moment. So yes, so I have a series called Ramda, or Ramda.js, whatever, something. I mean, it's a whole series on Ramda.js, lots of videos. I think now we're at 41 videos. So episode number 1, episode number 27, and episode 19. I just did a quick search through them, and those seem to all be important or related to the ideas of composition, partial application, currying, and of course piping then, right? So what we've talked about here in terms of left to right composition and right to left composition. So if you're not familiar with any of those things, then I would definitely check out those episodes. Of course, I mean, I'd highly encourage you to check out that whole series, because I find it to be a pretty interesting journey. But I mean, who am I to force you? Okay, so this seems to work, this transform, and then I think we should actually rename this transform function. So let's just search for transform, and let's rename that to Juxt. So juxtapose here, Juxt here, and then we have it elsewhere, right? We have it here, Juxt. Okay. So, and then let's line this up like so. Let's remove this console log statement. Now we have a bunch of white space here that we can remove, like so. And then I guess then this would work. Then we don't need this example that we had before, but what we can do now is we can see if we still have the same results when constructing our transformer by juxtaposing instead. And it seems yes, right? I mean, I'm just eyeballing this now. I'm not actually going point by point, but maybe I should. I mean, I still have this paper here. Let me just sort of eyeball again. 3, 1, 3, -1, 1, 1. Yeah, it seems sensible, right? So, okay, so then even, I guess, I mean, if we're not concerned about performance, I guess instead of constructing the transformer, we could even do something like inlining the juxtaposition here, juxt transformations, and then we apply that function, right? And then we don't even need the transformer, and then that still works as well, right? It's like, again, like we're just simplifying things a bunch. But anyways, okay, that was an interesting journey. Let's maybe keep it like this, like explicitly constructing the transformer. Let me now close this juxtaposition. Maybe before we do that, let's check out what the Ramda implementation is of Juxt. I mean, again, like they're concerned with performance, so I assume that maybe they have a different way of implementing it. Okay, they've actually implemented it in terms of converge. That's very interesting. There's also I also have a Ramda video on converge, and converge is a pretty cool function, so maybe you're interested in checking that out. But okay, let's close that. Let's close the Ramda documentation, because now we've understood. Now we've understood juxtapose, and now we are at this point, right? So the reason, what is going on here? I want to make this, like so. Okay. So I mentioned that I gave it a bit of thought that you could probably solve this using cosine and sine, and so here's the Stack Overflow post, right, or question that asks, how can you rotate a point on a circle with a known radius and position, right? So this person's problem is a bit more difficult than ours because the position is known. So, or actually, sorry, maybe that's not the way I should say it. This person's origin of the coordinate system is not necessarily 0, 0, which makes it a bit more difficult because then they have to translate it. Actually, we have the same problem, but we're going to separate those and not do that in the same calculation, right? But we'll get to that point later. I mean, visually, because I say that because the coordinate system in a canvas, like the 0, 0 point is up here, right? If you notice where I'm drawing with my mouse, and not here, right? So the origin is sort of in the top left corner and not in the middle of a canvas. And we're actually going to have to need it in the middle, but we'll take that later. I think we'll solve that sort of maybe visually even. Okay, so okay, yeah, I mean, so if you just look at this example that he has here, or that this person has here, this makes perfect sense, right? It's like, assuming that you have this point, for example, let's say B, right? Assuming you have this point, how can we rotate this point down here, right? That would be a rotation of 90 degrees. And if we do that 4 times, or 3 times rather, actually, right? I mean, we have the original point, we rotate it down here, 90 degrees, then we rotate it again 90 degrees, or actually then we rotate it 180 degrees, and then we rotate it again 90 degrees, where is that, 270, 260, whatever, and then we rotate it back, right, and then we have the original point. So if we would do rotations in terms of 90 degrees, like 3 rotations in terms of 90 degrees, then we would end up with 4 points, right? Or let's say, I mean, if we take the original as well, 4 rotations, 90 degrees, right? That gives us 4 points. But if we did 8 rotations at 45 degrees, then we get 8 points, right? Because then we have a point here, 45, we have a point here, we have a point here, we have a point here, 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 and here, right? And that's starting to look a lot like what we were aiming for. And then when I started to think about this, I was like, okay, but let's look at some other mandala online, or Mandala Maker. And then I found this Mandala Maker, so mandalamaker.online. And here, this is just the default settings that they have. If I start to draw here, you can see it's pretty cool, right? And they, immediately you notice that they have more sort of sectors or lines than we had in our example, or that the original blog post had in its example. So let me clear this. If you can actually alter the settings here. I'm sorry, I'm not sure if I can. Yeah, it seems like I can't zoom in here. They haven't really made it responsive, this thing. But if I reduce the number of sectors here, so it was 16 originally. Let's say we go to something like 6, right? I'm not sure if you can see that, but there are some lines here. There are 1, 2, 3, 4, 5, 6 lines, and also then 6 sectors, 6 pies in this pie chart, let's say. And if I start to draw now, you can see we have fewer lines, right? Let me clear that. And if I draw, yeah, I was going to say this, right? Let's find another example where this is the case. Let's go to 5 maybe. Whoops. Clear. Yes, here, this is what I was looking for. If I go to, for example, 5 sectors, and then I draw on a line, like directly on a line, you can see that what we get is this, whoops, mouse, running out of mouse mat. Okay, so mouse pad, mouse mat, whatever. You can see that these are sort of equidistant, right? It's like there's the same angle between every one of these lines. So how many lines do we have now? 1, 2, 3, 4, 5, 6, 7, 8. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, all right, because we have 5 sectors. So actually, if I wanted 8, then we should have 4 sectors. Yeah, but then I'm probably not going to get this. Yeah, then I'm going to have this mirroring issue. Yeah, okay, so then the idea would be, no, sorry, so then I have to draw like this. Nope. What am I, wait. Like this. Yeah, but here it's more difficult to get it equidistant because I don't actually have a helping line. No, actually I can't. Wait, okay, so, yeah, so the tricky portion here, I guess, is that I am actually not entirely understanding the way this thing works, because there are 2 things that operate in this Mandala Maker, right? There's this mirroring checkbox that you can check, and then there's also the number of sectors. And I think this is somewhat related to the fact that we've thought about that you need the inverse function, and then you need reflection over axes. So I would guess that this mirroring is somehow the inversion, like using the inverse function. But then the sectors is in regards to reflect. But instead of doing reflection, they're doing rotation. Again, like in accordance to, or given some particular angle, as we talked about when we looked at this circle. So I think maybe let's skip the mirroring for now. Let's only do the rotation, because that will give us this scenario where when you're drawing one line, you'll always draw the same line rotated on the same sort of circle, right? But we won't be getting this effect. Like if I say mirror, and then we go to, for example, 4 sectors, I don't think we'll get this effect. That was not clear. Where 2 lines are very close to each other, right? Because it will always probably be sort of equidistant, or that, and the angles will always be the same, because we'll be saying rotate by a particular angle. But let's take one problem at a time, right? I think let's try and do this, and then let's think about how to do it with lines close to each other, right? So that we can also have this scenario, right, where the angles are not equal throughout the whole, or between every line. Let me just let the cat in, and then maybe think a bit about how that could be solved. Okay, sorry, so that was actually not a rhetorical question, because I don't really know the answer to that question, but it probably, again, has something to do with this mirroring, or maybe using the inverse function. But let's try to do this on a circle thing. And I think actually what we're going to do is that I think we have a sufficiently well abstracted, or like our code is now sufficiently well abstracted to warrant moving into the visuals, and then making sure that we have something that's visual, and then we can worry about changing these transformations, the way we construct these transformations. And the reason I say that is that I think we should start to look at something visually now, so that we don't have to just rotating something by 90 degrees, then it's trivial. So I mean, if we look at this, right? When we had this diagram, right? So if you have this point up here in the top, like not the points that I've drawn now, but some arbitrary point up here in the top, like at x0, and then you rotate that by 90 degrees, then of course it's trivial to figure out that it should be here, such that if you have, let's say, x0, y3, then when you rotate that 90 degrees, it should become x3 and y0, and so forth, right, throughout the circle. But if you rotate something by like some arbitrary degree, it's difficult, at least for me, to sort of just immediate or ballpark whether that thing, or eyeball whether that thing is just correct or not, right? Whether the rotation is correct. So I think that's probably going to be easier to show or to visualize, and then we can sort of say, oh, okay, well, actually, it seems like we've implemented this rotation correctly. So let's move into that. And I've opened up the Mozilla docs or some tutorial on Mozilla in the Mozilla docs for how to draw a bunch in the canvas, because I don't actually know how to draw in the canvas. So I guess let's jump into that, right? I believe the file that we have now is called main.js, right? So we have a main.js file. Let's now also open up some index.html file. And let me just, I guess, construct a simple HTML document. So maybe I should have prepared this beforehand. My apologies. So where's that? Like, we need a meta char set, UTF-8. Maybe I'm missing something now, but like, never mind, right? We need a title, and this title maybe should be Mandala Maker. Title, close the head, and then some body, right? Oops, body, okay, and close HTML. Okay, so we have a simple HTML document, and maybe we need to load the JavaScript, right? Let's do that in the end, so we don't have to think about it when things are loaded. So I'll load main.js. We'll close the script tag, and then let's actually put a header here and say Mandala. Let's make a p tag because I'm gonna probably zoom in. Mandala Maker, and then let's add a canvas here. So let's say canvas with an ID. Actually, I mean, never mind. Let's just say that we have a canvas. Okay. Let's say with an ID of Mandala, and then we'll close that canvas. And of course, we need to have a size on that thing. So let me say, maybe depends on how much we zoom in, but let's say 200. Let's actually make it a square, right? So 200 times 200. Okay, and let's open up this file in a browser. So let's see what that looks like. Then we have this Mandala Maker, and then let's maybe I'll just increase the font size of that a bunch. Then maybe just let's add some basic styles here, and I'm not gonna make a separate style sheet. I think we'll just do it something like this. What is up with my indentation? Okay, and then we will say, so let's just say something like canvas has a background of some light gray color. Let's try that out. Yeah, okay. So yeah, but okay, sorry, actually let me make a style sheet instead. This is a bit ridiculous. So let's say link rel style sheet, and what is it, href, src, href, right? And then let's just say, let's actually do this. Let's say index.css, and then we'll put that in there instead. So we'll save this, we'll open up a file called index.css, we'll paste in that style, whoops, like so, and then we'll go back to main.js. Nope, we'll go back to index.html. We'll remove this old sort of inline style tag, not inline, but in document style tag. And then I think I also want to rename main.js to index.js. Let's actually do that as well, right? So let's go to main.js and let's rename that to index.js. So if I background this application, let's clear the screen and let's just look at the files that we have. Then we have index.css, index.html, and index.js, right? I just named them all index instead for clarity. So, okay, so that should still work. If I refresh this, we still have a gray background. I don't know how whether the canvas appreciates that it starts as gray or whether that's a problem, but we'll see. I don't think that's necessarily a problem. Okay, so let's now try to draw something. So the question, I guess, is whether we should keep working in this index file or whether we should consider this the sort of Mandala library and then we should put some code in another file. And maybe we should probably do that, but I'm just actually going to use this file directly. So I guess, yeah, I mean, we can keep these console logs statements, no worries. But what we're going to do now is we're going to draw on the canvas. So let's just make an example, right? Like, let's just let's just maybe, as they were saying here, draw a triangle, but we don't actually care about triangles. So we actually just want to draw some line, right? But let's grab the canvas. So let's say canvas is document.getElementById, and the ID is Mandala. And then we have that canvas, and then we want to say canvas, const, let's say ctx for context. So the context is equal to canvas.getContext, and of course we're gonna have to abstract this into some functions or something like that. So because now we're sort of doing everything straight up, but yeah, I mean, we have to start somewhere. And then we say, oh sorry, get context, and I pass the string 2D apparently. And then we can start to draw, right? So then we can say, okay, ctx begin path. Maybe I should actually move to somewhere first. So let's say ctx.move to, and I want to move to the middle of the screen, but I have to let the cat in first. So to get to the middle, I guess it would be entirely possible to ask the canvas what its width is, width and height. But I guess let's just start by hard coding. So we worked with, let's see, index.html. We worked with 200 and the 200. Hang on, I have to move the cat. Whoops. Okay. So okay, let's not hang out with the cat now. So 200 and 200. Whoops, the old file, index.js, refresh, like so. Okay, so we want to say move to, let's say 100 and 100, and then begin path, and then we move to, no, we line to, okay, we line to, let's say, I mean, let's go to 0, 0, right? So then we should have this diagonal, and then, yeah, I guess that's it, right? Then that should hopefully show. So let's try that out. I'm not actually seeing anything. Interesting. So do we have to set a color? No, I mean, I guess the color should be, okay, sorry, we have to say begin path. So ctx begin path. And the question is, if I just want to draw a line, okay, sorry, so then I'm there. Yeah, so sorry, I should have found an example of drawing a line. Here they're drawing a line. Yeah, stroke. Okay, so we have to end by saying ctx.stroke, like that. Okay, so like stroke and fill, I guess. Let's check the console. No errors. What am I messing up? Okay, begin path. We're doing begin path. Then we're saying, they're saying arc, but this is, yeah, can we please have an example of a line? Begin path, move to, line to, oh, sorry, I said begin path twice. My bad. Move to line to. Yeah, okay, that's probably the problem. Yeah, sorry, okay, so that works, right? And this looks pretty ugly because I've zoomed in a lot, but actually it looks like this. But let's keep it zoomed in for now, and then let's figure out how to deal with that later. So that's pretty cool. Now we know how to draw. So then I guess this is some basic canvas setup, right? I guess maybe we should put that in a function in like get canvas or get context, right? Context. Yeah, but let's actually do this. Let's keep these. I'm just gonna make these uppercase variables and keep them as sort of, let's say, procedural globals, right? Of course, you shouldn't do this, right? But it's like at some point we have to interact with the end user, or we have to interact with the web browser, and then we can draw, right? But so then I think what we're going to do is something like, we're going to have to use like a pen, so a bunch of pens, and then you can ask a pen to draw from its last location, because somewhere we need to remember sort of where the last location was. I mean, if we're just drawing lines, then that's sort of trivial, right? Let's do that. Let's actually do that, right? So like, let's say we have a function which is called draw. Let's just say line that takes some x. No, that takes some position 1 and some position 2, right? So let's say P1, I'm going to do this curried. So position 1 and then position 2. And what it does is essentially then that it interacts with this global, it interacts with this global variable context, and it draws using those 2 points. So let's say ctx, begin path, move to line 2, and then we're gonna say, okay, draw from p1 and then line to and then line to p2, and then fill that with stroke. So that's probably gonna make sense, right? Now we're of course not drawing anything, but that means we can now say line from x0, just make this compact, from x0 and y0. No, wait, sorry. We have to call move to px p1.y, right? Because they accept 2 arguments, and then p2y, like that, right? Okay. So we're saying line from 0, 0 to let's say 200, 200. And then maybe let's do exactly the same thing, but the opposite, right? So here we're saying 200. No, not that. I mean from in the other direction. So 0, 200. Yeah, sorry. x0, y200 to x200, y0, right? Then we should get a cross, I guess. Errors. Do we have errors in the console? Let me make this bigger. Canvas is not defined. Yeah, okay, sorry, of course, because here I called it canvas uppercase. Let's save that, let's refresh. No errors, but we're not actually drawing anything. We take one variable, we take another one. Context, begin path, move to. Did I not move to first the x and then the y? And then, oops, why do I have so many arguments here? Did I accidentally press something here? Like so, right? That was probably the error. My bad. Yeah, okay, and that works. Fine. So let's close the console. Okay, so now we have that. And I guess the issue here is that, so we have this list of transformations, right? And if we just want to draw those, that's not a problem, right? Because it's like we want to say, take, like map the function line. No, but okay, let's think about this. Yes, right? It's something like that. So like, let's say we have the partially applied function line that starts from 0, and then we want to apply that using our transformations. But hang on, wait. Yes, I mean, oh, no. So what I mean is this. We have, let's say, points is equal to our transformer applied to some given points. Let's maybe remove this transformer now, and then let's just directly use juxtaposition. Or actually, let's do it like this, right? So we call the transformer and we pass in some starting point. No, not some starting point. We pass in the point that we want to transform, which is, let's say, arbitrarily, what are we going? We're going from 0 to 200. But now we immediately get into this point where it's tricky, because we have, like, the origin is up in this top left corner, but we actually want the origin to be in the middle. So we're going to have to do a bit of translation. But let's just not think about that now. Let's try and see if we can get some points like this instead. So then let's do maybe, I guess, x 100 and y 100. Let's try that out, right? Whoops. Let me actually compact this like so. Sorry, white space. So we have those points, right? And then if I just console log the points, actually let's do that in Node, I guess. No, okay, but then now we can't use Node anymore, because then the document is not defined, and this is then a great example of why you should separate these two things, like the visual stuff and the library stuff, into two separate files. So let me remove those other console logs, and let's just console log these points. Let's refresh. So what do we have here? 100, 100, 100, 100. Yeah, I mean, we have those points. So now we have a list of points. And then we want to map drawing over all of these points. So how do we do that? We do something like points.map the function line from x0, y0. That should work, right? Let's not console log them. Let's try this out. We get this one, but maybe that's actually all the ones we have. So if I line from, so now we line from 0, 0. Let's line from, I mean, if I line from 100, 100, that doesn't make any sense because we're lining 2. Ooh, wait, I'm so confused. Why do we get all this stuff? So now, because now we would be saying, let's go from 50 instead. So 50, 50. That maybe at least makes more sense. Ah, okay, maybe I'm also, am I manually drawing something? No, I'm not, right? If I remove this stuff, we're not going to draw anything. Yeah. So I'm not manually drawing anything. And what happens is that we're saying every time we say line, we've partially applied with 50, 50. So we're going to start from 50, 50. Yeah, okay. Yeah, it's again, no, it's again, it's the fact that we need to translate everything. Yes. So actually, maybe let's put that in the line function. So let's do the translation directly in the line function, because we actually want to read coordinates as if, like when we're going to interact with the mouse, we're going to read coordinates as if the origin is in the middle of the canvas, and we're gonna write coordinates as if the middle is in the middle of the canvas. So that means that we have to shift everything by half of the canvas in vertical and horizontal direction, right? So we have to shift everything, and I guess it would be that simple. I'm hoping it would be that simple. Let's try that out. Let's see just first if we can we get the width of the canvas. I guess in this article we should be able to see. Let me go for width. Yikes! I guess it's just canvas dot width. Okay, never mind. So a bunch of stuff in there, but okay, let's do console log. Actually, let's explore here. So if I open up the console, we should have the variable canvas uppercase. Yep. And if I say width here, do we get the width? Yeah, and canvas dot height. Yeah, so that's fine, right? So that means we can access the global variable canvas. Again, you should work on isolation here. There are definitely a bunch of things we can do. But if we just want to shift everything, then yeah, I guess we would just say whatever x you say, I want to draw on that x plus canvas dot width divided by 2. And same thing for y, plus canvas dot width divided by 2. And then same thing for line 2, plus canvas dot width divided by 2, and y plus canvas, oh sorry, canvas dot height, of course, divided by 2. My bad. Height should be here as well because it's y. So let's save that. Okay, can we draw something like let's say line from 0, 0. Actually, 0 is a good example, right? From 0, 0 to x 100, y 100, right? That should be to one end. No, errors. No, sorry, partial application. I have to run it like this because we're not auto-currying. Yes, okay, that works fine, right? Very, very good. Okay, and let's go to negative 100 and negative 100. And that should give us the other end. Super good. So that seems like our translation is working fine. What happens now? Let's maybe keep this in case I want to draw something again. Let's, so I'm sort of regretting that we send in points instead of sending arguments because you have to build up the structure every time you want to draw something. But let's now draw the points here. And then I guess we need to line from the new origin, so the middle of the screen. Let's see what happens there. Yes, this is actually very good, right? Because let's think about this. Let's bring up the old paper that we were working on. Sorry, the cat is sitting on the paper, so I have to make sure we agree on the fact that I can't have the paper. So does this make sense or not? We're actually drawing, no, it doesn't really make sense because we are drawing 4 points, but in actuality, we should be having 8 points, right? Because, I mean, we constructed the variable points. So if I just look at in the console now what points contains, it contains 8 points that are, let's think about this. 100, 100, that would be here. But then here is the same point. 100, 100, 100, negative 100, 100, negative 100. Ooh. So maybe when I switched to juxtaposition, I probably messed this up. That was super unfortunate. I wonder if it was messed up before or if I just messed that up now. Or is it, no. Or is it because, no, sorry, maybe that's not the case. If we say x0, let's refresh. Let's also console log points. No, but it probably is that. I've messed something up. No, but now we have different points, right? So if we don't go from 0, 100, if we go from 50, 100, come on, 50, 100. Yes, okay, no, it does work, That was expected behavior. We're just drawing two lines on top of each other. So this is really good, right? So now our point 0, 0 is the last point we were currently at. For us, it was now the origin. But I guess, yeah, this is, yeah, and but what it should be is that it should be the last point that particular pen was drawing in. If we think about it in terms of 8 pens now drawing individually. So I think this is maybe a good place to pause, and then we're going to pick this up in the next one, and in the next one we're going to try to figure out how to make pens that sort of in some sense then remember their last position, or somehow we're gonna have to make like keep state of the last position, unless of course, I mean, what we could do, which would be interesting, what we could do is we could just redraw the entire thing. Like we could just interact with the user, and whenever the user is changing, whenever the user is moving the mouse, right, or drawing, then we construct a new array, or we append to the array that we're constructing, and then we are just redrawing that entire array, sort of like Redux style, right? We're sort of re-rendering the DOM. But I don't think in this particular case that's a good approach, because that's probably going to be, or I mean, evidently that's going to be less performant, but it might even be so poorly performing that it's that it's catastrophic, right? So I think here we should make use of the fact that we can visually store the state in the canvas, because we don't really care, like we don't want to change the previous points, unless we of course want to implement undo or something like that. But I think given the current way we're thinking about this, even if we use something like pens, I think we're going to be able to do that quite elegantly. Again, like the power of functional programming. Okay, or I mean, in some sense, the power of many levels of indirection and highly abstract programming. Highly abstract, I don't know, abstract programming the way it should be done. Okay, let me now close this. Thanks a ton for watching. Let me know what you think about the series in the comments. If there's something you don't like, let me know so I can make this better. Thanks for watching. You know what to do, and I'll see you in the next one.